All right, I'm back. I realized as I was saving that video that in the warm-up for practice for your quiz that I did in problem 2, I did part A, but I moved on to problem 3 without finishing part B. So we don't want to leave that one. So let's go back in part B. We're going to use the same region we had, so I'm going to erase my washer method off of the graph, and we're going to be using this region as the base, and what we're going to build on that base are going to be cross sections perpendicular to the x-axis, so still these Riemann rectangles, but then vertically we're going to build semicircles on top. So remember how, and you don't have to take time to draw this, but remember that we have this line at y equals 2. Let me see if I can kind of squeeze these both in here. So we would have some sort of region like this, and then what we're building here is this Riemann rectangle is, and each of them, every one of those Riemann rectangles is going to have a semicircle built on top of it. So this represents many of these cross sections as we go across from 0 over to our A value here. So again, in part B, we don't have to rework A. We already had that intersection point. So notice that this point and this point have the same x coordinate. So this point is x comma f of x, and this point would be at x comma 2. So the only thing I think that students might have trouble with is remembering that this distance from 2 down to f of x is not the diameter, that is, or not the radius, that is a diameter. So if we want to do a semicircle, we have to divide this in half. That diameter has to be cut in half. So now for part B, we're going to add up all of these semicircles in an integral. So our volume by cross sections is going to go from 0 over to A, and we're going to do semicircles. So I want to do 1/2 pi r squared here, and we only have to set this one up. We don't have to do any of the work. So my suggestion here is let's just write it without doing any of the cleanup. So there's our semicircle, 1/2 pi r squared. You could put this in square brackets, but the dx actually serves to show where our integrand ends. So that really is all there is to it for adding up all. Remember, this represents not just one semicircle, but every semicircle as we move across that region. That's it.